Hi guys, this is Mr. Urrego, and today we're going to work on double angle identities. As you can see, we have the sine of 2 theta, cosine of 2 theta, and tangent of 2 theta. So these are the identities for those double angles. Sine of 2 theta could be 2 sine theta times cosine of theta. Cosine of 2 theta has 3 different identities. Cosine squared theta minus sine squared, 1 minus 2 sine squared, or 2 cosine squared minus 1, depending on whatever we need. And tangent of 2 theta is 2 tangent theta over 1 minus tangent squared theta. Theta, remember, is the angle. That's all what the theta means. That could be an x, that could be a y. Alpha, that's just the angle. How do we use this? All right, let's use them. So first example, let's write the expression as the sine, cosine, or tangent of a double angle. Then find the exact value of the expression. So write the expression as the sine, cosine of a double angle. So I have an expression. What is this? What it belongs to? So first of all, I want to bring my identities. Okay? And I want to see which one is similar. Okay? So I have 2 sine 15, cosine 15. The only one that has sine and cosine not being, so squares, no, not squared, not squared, not squared, tangent, no. So it's the first one, 2 sine 15, here we go. So my identity is telling me that sine of 2 theta is equal to 2 sine of theta times cosine of theta, which I have this, I have the right side. Okay, so let's send that away. Here we go. So in this case, my theta is 15 degrees, right? It's 15 degrees. Therefore, sine of 2 theta means 2 times 15, right? The identity is the same thing. So my answer to this is sine of 2 theta. Sine of 2 times 15 is the same as sine of 30 degrees. And according to my 30, 60, 90 triangle, if this is 30, across is 1/2, which is my sine, opposite over hypotenuse. Alright, sine of 30 is 1/2. Alright, I have the sine. Boom, done. Next one. So again, it's just a matter of seeing which identity is closer to this one. Another example, find the exact value of the sine of 2x, cosine 2x, tangent of 2x, if sine of x equals 5 over 13, and they're also saying that the x lies in quadrant 2. So first of all, let's see where this thing is. They're saying quadrant 2, therefore this is quadrant 2. Okay, this is Q2. My angle, in this case, this is the angle x, right? X degrees. That's my angle, and they're saying that the sine of x is 5 over 13. But remember, sine of the angle is opposite over hypotenuse. In our case, they're saying that it's 5 over 13. They said my angle lies in Q2, that's why it's in Q2, right? To the left. This is Q1. So this is Q2, reference angle, is with the x-axis, that's my angle. Sine of x, opposite over hypotenuse, opposite to the x is this. Opposite is 5, hypotenuse is 13. Therefore, hypotenuse 13. They want me to find the sine of 2x, cosine of, well, to find all those, oh, come on. All right, so this is the first one. To find those, I need the third side of this triangle. Okay, I have the opposite, I have the hypotenuse, I need to find this bottom part. Therefore, I got to use the Pythagorean theorem. Okay, what's the Pythagorean theorem? A squared plus b squared equals c squared. A in my case could be 5 plus b squared, let's call this b in this case, the bottom part, and c is my hypotenuse, which is 13 squared. 5 squared is 25 plus b squared equals 13 squared is 169 minus 25 on both sides. B squared equals 144. Square root of that, b is equal to 12. Okay, so this is equal to 12. But remember, because this is going to be in Q2, then this dimension of that is going to be negative 12 because I'm going to the left. And that side is going to be negative. Alright, cool. Let's find sine of 2 theta. Sine of 2 theta. So in this case, it's going to be my x, my angle is x, right? So sine of 2x is equal to 2 sine of x. Sine of x. X, sine is opposite over hypotenuse. Opposite over hypotenuse. Times cosine of x. Oh, but what's cosine of x? Cosine of x is adjacent over hypotenuse. This is x. Adjacent is your b side, which is negative 12 because it's in Q2. Cosine of x is adjacent over hypotenuse. Adjacent, Q2 is negative 12, hypotenuse is 13. Just simplify that, and that's it. So I have 2 times 5 times negative 12, that's going to be 10. That's going to give me negative 20. 13 squared is going to be 169. If I can reduce this, I reduce this. If not, that's my answer. So sine of 2x equals negative 120 over 169. The main idea is to find the triangle. That's the whole work about this thing. After that, it's just using the identities and solving them. Alright, so let's get an eraser here, erase some of this thing. So let's erase this. Now the next one is going to be cosine. Alright, to do the cosine, I want to bring my identity. So here we go. Identity of cosine. My next identity is cosine. So for cosine, I have those three options. Which one do I use? It doesn't matter which one I use. It doesn't matter which one I use. It's going to be the same thing. I believe here I have cosine and sine. Let's use the first one. So cosine of 2x is equal to cosine squared of x. Remember, my angle in this case is x. Alright. So cosine square, I'm going to use the first one. Let's cross this one, let's cross this one. Cosine square of x. Cosine square of x minus sine square of x. Cosine, adjacent over hypotenuse. Adjacent is negative 12 over 13. Adjacent negative 12, hypotenuse 13. Negative 12 over 13. Remember, it's to the second power, so this has to be the second power. Minus sine square. Sine again. Sine of x is opposite over hypotenuse. Alright, opposite. 5, hypotenuse 13. 5, 13 to the second power. Negative 12 squared is going to give me 144. 13 squared, 169. 5 squared, 25. This is a 13. Square is 169. 144 minus 25 is going to give me 120, 119 over 169. So cosine of 2x is 119 over 169. Can you reduce that? Not really. That's my answer. So right now it's just applying my identities. Let's erase that. Let's use tangent. Oh, I erased it, the whole thing. Let's do tangent. Tangent, tangent, tangent. Okay. So I erased the whole thing. Okay, I brought back the triangle. Alright, so tangent. Tangent is 2 theta, 2 tangent of theta over 1 minus tangent squared theta. What's tangent? So let's write it over here. Tangent is opposite over adjacent. Okay, so let's do this. Alright, tangent of 2 theta. Tangent of 2x in this case, right, is equal to 2 times tangent of theta, my angle. Tangent of x is opposite, which is the 5, over adjacent. So tangent is 2 times tangent, which is opposite over adjacent, 5 over negative 12. 1 minus tangent square. Tangent square, again, my tangent is 5 over negative 12. 5 over negative 12 square. The top, I got 2 times 5, which is 10, over negative 12. Remember, I don't want to have a negative in the bottom. So you know what, let's keep it for now. 2 times 5 is 10, and the negative 12. The bottom, I have 1 minus 5 squared is 25. Negative 12 squared is going to be 144. Alright, let's continue on the right side. On the left side, I'm sorry. So what happens is the following. I'm going to simplify the top. 10 over 12. You know what, let's keep it like that. Let's keep it like that. 10 over negative 12. And the bottom, because I have this fraction, 1 minus 25 over 144, I got to turn this one into, my denominator is 144. That means I got to multiply times 144 on the top and 144 on the bottom. Meaning, 1 unit is 144 over 144. 144 over 144 minus 25 over 144. The top, let's keep that 10 over negative 12. And now 144 minus 25 is going to give me 119 over 144. Now here it's just a matter of reducing or dividing. Okay, so the first times the last. 10 times 144. Alright. Ten times 144. Right, and the middle value is going to give me negative 12 times 119. Okay, let me keep simplifying. Half and half, that's going to give me 5 over 6. Let me bring that negative to the top. And then 144, can I really simplify this? I can simplify it divided by 2. So let's simplify that for a second. So 5 times 144 is negative 120. 6 times 119 is going to give me 714. Okay, the idea is to keep reducing this fraction, alright? And divided by 2, this is going to be 360. Divided by 2, and it's going to give me, let me see, 357. I'm not really sure if I can reduce this. 12, divided by 3 is 120. And divided by 3 is 119, and I believe there's nothing else that I can do with that. Therefore, tangent of 2x is equal to 120 over 119. Okay, so that's the idea about those ratios. The main thing is to make the triangle. That's the main thing. And find the 3 sides. And make sure that you use the quadrant. Okay, you use the quadrant. That's how we know that. That's how we knew that this piece was going to be negative, because remember, in the Q2, your sine or your y value is positive, but your x value is negative. Here is negative, positive. The x is negative, the y is positive, to make sure. Okay. All right, that's it, guys. Like my student says, smash that subscribe button. You're going to see it here in front of the screen. And also there's going to be on the pre-calculus library. Okay, next video I will prove some identities using double angles, so stay tuned for the next video, proving identities. Thank you for watching. Subscribe, make sure you subscribe to the channel and like the video, guys. Take care, bye.